So let's take a look at defining how we deal with the type 2 improper integrals. Okay, so first off, if our function f is continuous on the interval, let's say from a to b, but not at b, then how can we evaluate the improper integral? Well, we would take here the integral from a to b, we have our discontinuity occurring at x equal to b, so we can introduce our parameter, let's say t, and then what we do is a limit as t approaches b. Okay, now again, this is going to be here a one-sided limit, so you have to figure out which one it's going to be. If you have any doubt, okay, just go off to the side, consider your original interval was here from a to b, and we have the discontinuity occurring at b, so what we did was we introduced our parameter t just to the left of b, knowing that if we do that, we have our function now is continuous from a to t, and so t is specifically going to be approaching b from the left. Okay, so this is how we will first deal with our discontinuity, and that is if our discontinuity occurs at the upper limit of integration. Let's take a look at what happens if it occurs at the lower limit. So number 2, if our function is continuous on a to b, but not continuous at a, then we take our integral a to b, and we do something very similar. Okay, we're now just going to introduce, though, our parameter for a. So let's say we can use a to replace it by s. We do integral f of x dx. We use FDC2 there, and then we take the limit as s approaches a. And this time, again, if you have any doubt, we have a, we have b, and we're staying away from a because that's where the discontinuity is. So in this case, s will be approaching a from the right. Okay, and so that is our definition for how to deal with a discontinuity at the lower limit of integration. One more thing, okay, sort of the worst case scenario, but this is also what happened with 1 over x squared. Okay, the third possibility, what if you have a discontinuity somewhere inside the interval? So here we have f of x, and let's suppose that we have our discontinuity at x equal to c, where c is somewhere inside of our interval. Well, what do? Well, we just split it up. Okay, this is very much what we did with that 1 over x squared term. So we started off with a to b, f of x dx. We have our discontinuity. Again, let's sort of picture it like this. We have a, we have b. We have a discontinuity maybe somewhere in the middle at c. So what do? Well, we just stay away from c. We can introduce here a parameter to the left of c, introduce here a parameter to the right of c, and then we can take our limits. We'll have essentially two different integrals. Okay, so we would say this is going to be integral from a to c, except we're not going to use c, we're going to use t. And we're going to do the limit as t approaches c from the left, f of x dx. We're going to add that to a second limit. Here, not involving t, we're involving s. S is going to be approaching c, this time from the right. And we're doing the integral from s to b, f of x dx. Okay, so we essentially have just taken our one improper integral with the discontinuity inside, and we split it up here into two different improper integrals, and we deal with those separately. Okay.